Hello guys, this is Paul McWhorter from TopTechBoy.com, and we are here today with lesson number 11 in our incredible new tutorial series where you are going to learn artificial intelligence on the Jetson Nano. I will need you to pour yourself a nice big mug of iced coffee, and I will need you to get out your Jetson Nano gear. What? You don't have the gear yet? Look down in the description below and you'll see links to the hardware that I am running. If you're going to play along at home, it does help if we are working on identical hardware. Also, want to give a shout out to you guys who are helping me out over on Patreon. It is an incredible support. It's an incredible encouragement to me, those of you who decide to become a part of this channel by helping me out over at Patreon. Those of you who haven't yet, think about going down in the description. There's a link to my Patreon account. Think about running over there and hooking a brother up. But enough of this shameless self-promotion. Let's get into what we are going to learn today. And I am telling you, I am so excited about today's lesson because the first 10 lessons have really been just kind of laying the groundwork, laying the foundation for getting into the artificial intelligence. And we're really going to do some exciting stuff today. We are really going to get into it today. And so what we're going to do is I'm going to show you how to launch and work the Raspberry Pi camera from inside of Python using OpenCV. And so I will probably need to get out of your way here. Okay, I think that will work. What I need you to do is go over and open up Studio Code, Visual Studio Code, which we installed a few lessons ago. All right, and it should come up like this. And if you look, I am coming up in that demo program that we did last week. I'm going to close these other tabs. Okay, let's see. Close that one. Okay, so this was the demo program that we wrote last week just to show that we had been able to install and install and import OpenCV running Python 3.6. And so if I right mouse click and say run in Python file, and what you can see is that it prints out down here that we are on version 3.3.1 of OpenCV, which is what we want. Okay, now we're going to go in, and if you look, you should have some setup like this where you've got the Raspberry Pi camera hooked up to the Jetson Nano. And remember, we kind of did the physical build in lesson number 1, which was a particularly painful lesson because I think I had to take apart the acrylic case like 4 times and put it back together in order to get it put together right. But we did persevere and we got the physical build done. And so you should have a setup that looks like this. All right, now what we really want to do now is instead of just having the little Raspberry Pi camera sitting up there looking cool, we want to make it do something. So we can just use this OpenCV1 program. And guys, what we're going to do today is this is going to serve as the starting point for all of our future lessons because we're going to set up a basic core program that will go out, fire up the camera, and read a frame and display a frame. And so we'll have kind of like a little thing that does the core elements that we're going to need for all the future lessons. So you need to save a copy of this program and then always, work from a copy of it. Don't modify this program after today because we want to kind of have this core starting point for all the future lessons. All right, let's jump in here and do something. First thing you want to do is import OpenCV, which we do with the import CV2 command, so that's already done. Now, in order to fire the camera, there's like a whole bunch of parameters that we're never going to change, but there's kind of 3 parameters that we will change. And so the first is we're going to call it display width, and that's how wide the display is when it is shown on your screen. And I'm going to put kind of a small one. I'm going to put 320, and then I'm going to put display height, and I'm going to say 240. Now when we run the program, we can come in and make this bigger or smaller, but you want to kind of keep this aspect ratio. Okay, you want to sort of keep this aspect ratio, and that will serve you well. Now the other thing you want to do is you want to come in and say that flip equal to, and that's one of the parameters on the Raspberry Pi camera that as we've built this, if you don't put a flip method in, your picture's going to come up upside down. And if you put flip equal to, it'll come out looking like you want it to. Okay, now this is the hard command. So what I need you to do is I need you to type in this command. All right, and what this is this is setting up a string, okay? And we have a variable. Are you getting all of this? Are you getting it all? This is a long command, okay? We have a variable called camSet, okay? What camSet is it's a string variable. And what I'm going to do, even though you know I'm the guy that hates copying and pasting, I'm going to put this command down in the description. Now in the description it might wrap around, but what you've got to see is you've got to put it in Python. You've got to put it as one long line like you see me here. But because you're copying and pasting it, I do want to kind of go in and tell you what this is. And so this open apostrophe is like an open quote. This is starting the string, and the first part of it is nvarguscamerasrc. This launches GStreamer. Okay, it's a program called GStreamer to run the camera. This is just the command that launches GStreamer. Now, I could spend a year trying to teach you GStreamer, but I'm not going to do that. I'm just going to give you the parameters that will work, that makes GStreamer work. So then we have like a video format. It's called video/x-raw memory :NVMM. Okay, and then I actually don't want this, so this will not be down below. This was me playing around with a parameter that we shouldn't play around with, so I'm going to take that out. And it won't be in the one that's pasted down below. Now the width, where it says width is 3264, that's the native width of what's coming off the camera. So we're reading the full resolution that's coming off the camera. Now how does that relate? How does that relate to this W is 320? That's the display width, and the display height is the 320 and 240. We're reading it in as full resolution, and that way if we want to display it larger, we've always got the native resolution that we want. So we've got the native resolution of height equal 3264, or width is 3264 and height is 1848. Then we want to format it as NV12. We want to have a frame rate of 28/1, so basically that's 28 frames per second. The camera, I think, will run it like you can run it at 60 frames per second, but you can't run it at 60 frames per second at full resolution. And that's why I don't want you to really monkey with these values, because these are the values that will work for the Jetson Nano connected to the Raspberry Pi camera. Okay. Then we have this NVIDIA conversion, where we're doing a flip method. Now this is the one thing that you should sort of see. You see how I ended the string here, and then this plus is concatenating it with turning that flip variable, which above was set to 2. We make a string out of that and we concatenate it. So what that's doing is that's taking that flip variable above of 2 and is just adding it into the string. So we're going to have one string, but this allows me to change those variables above and it build the string based on those. I hope that makes sense to you, but this is just inserting that 2 from above into the string, and now we concatenate that with, again, opening the string. And then we have this videox raw, and then we have width. And again, this width is the width from above that we're going to display, and this height is the height from above that we're going to display. So you see I'm building this string as you're putting those numbers in above. Then we've got to format it as BGR, that's blue, green, red. Kind of confusing, but OpenCV works with blue, green, red, where normally we think of red, green, blue. And then we've got to use the video convert method, and we're doing video/xraw, and format again is blue, green, red, and then appsink. So you need to go down in the description, you need to copy this whole thing, and you've got to make sure that it pastes in as one line of code. Okay, now we're going to hit enter, and now we start coding again, and we stop copying and pasting. Okay, so now what we need to do is we need to create a camera object, and what we're going to do is we're going to launch our camera. So what do we call our camera object? Let's call it CAM. Okay, and what is CAM? It's our library CV2, right? That's OpenCV. We're giving like our first CV, our first OpenCV command, CV2 dot. And what we want to do is we want to do a video capture. And notice that the capitalization is important. It's capital V, video capture, capital C, capital V, capital C. And then how do we launch it? We just send that string camSet, right? camSet from above. We send that to the CV2.video capture function. And now I have an object called cam. Now when I want to do something, I just work with cam. Does that make sense? Cam is my camera. Now if I want to work with the camera, I work with cam. I hope that makes sense. And do you see why I did it this way? It's a very simple launch now. All you got to do is just get that long string, and then you got to send it to video capture. Now we have a camera ready to run. Now if you think of the camera is a frame, a frame, a frame, a frame. Or if we're going to want to read that, we're going to want to read it inside of a while loop. So what are we going to say? We are going to say while. And how long do we want to loop? Forever. So we say while true. When is true true? True is also always true. Don't forget your colon at the end. While true. What do we want to do? We want to read a frame. When you read a frame, it returns two values. The first is kind of a 0 or a 1, kind of indicating did you get a frame or not. But with this setup, we're really going to pretty much always have a frame. So you just got to put that variable somewhere. That first variable, we just call it RET, like what it returns. That's a 0 or 1. We won't ever use it, but if you don't, this function we're calling is going to throw two variables at us, so we better have it set up to catch two variables. The first is RET. We will ignore that, and then the second one is the image itself, so we will put that in a variable that we call frame. You could call it IMG, you could call it mypic, you could call it whatever, but because it's a frame, I'm going to call it frame. Now what is that equal to? Well, we got to go out to the camera. What's our camera called? CAM. We want to read a frame. How do we do that? Read. Open, close. That will go out, and that will grab the latest frame, the latest picture from the camera. How easy is that? Okay. Now, if we grab it, what do we want to do? We want to show it. How do we do that? Again, it's an OpenCV command. It's CV2. Okay. And then .im show. So I'm going to show, and what am I going to show? Well, I got to give it a window to show in, so we got to give it a name. So let's call the window PyCam, like that. And now let's go out past the quote, and now you have to say, what are you going to put in this window called PyCam? I have a window. It's called PyCam. What am I going to put in that window? What would you guess? You guessed it. Frame. That frame that we just got. So do you see what we're doing here? We're grabbing a frame, showing a frame. Grabbing a frame, showing a frame. I can't tell you how excited I am. Okay, so we're going to grab a frame and then show a frame. Now, this is the thing, and this is really important. You know, in our earlier programs when we wanted to leave Python, we would just kind of crash it with a Control D or something like that to just kind of crash out of the program from the command line. On a program like this, you have to exit gracefully, because we've gone out and we have created a window, and we've gone out and we've locked up the Raspberry Pi camera. And if you just kill the program, that's going to kind of have unfinished business out there that you've got to clean up. So you've got to gracefully exit. So what we are going to do is we're going to set up a key, and if you press that key, it will gracefully exit. So how do we do that? Well, we use a command, if cv2 dot wait key, and how long are we going to wait? We're going to wait for like 1 millisecond. All right. If that is equal ORD, I'll explain this in a minute, and then open quote, open single quote, and then a Q. So what cv2.wait key is, it just goes out for 1 millisecond to see, is there a key being pressed? And then if there is a key being pressed, it looks and it sees, is that key Q? The ORD just kind of like reports the ordinance, the ord number of the key. But when you do this, you don't have to worry about what the ord number is. You just say, if it's Q, then you go into this if statement. Okay, Q is for quit. And so what do we do in this Q? Well, what we are going to do is we are going to break out of our while true loop. Okay, we are going to break out of our while true loop. So it's going to loop and loop and loop and loop. And if you press a key, it'll read it. If you press a key, it'll read it. If you press a key, it'll read it. But if you press Q, it's going to what? It's going to break out. Break out of what? Break out of the while loop. So it's going to kill the program. But as we kill the program, we have got to clean things up. What is one thing we want to do? We want to let go of the cam. So I'm going to say cam release. And if you don't do this and just kill the program and then rerun it, it's like the camera's tied up, and sometimes it doesn't air out, sometimes it works, but it starts acting real strange. So you really want to do this. This is releasing the camera, and then what you want to do is CV2, and you want to destroy all windows. And remember, the capitalization matters. The case, the uppercase, lowercase matters. All right. So look at that. What I have is I have a little program. Are we going to run this? I think we should. We do need to hold our breath on this one. I've done a lot of coding. I wonder how many mistakes I made. This camSet I think should be right because I copied and pasted it, and it'll be down in the description down below. And see, let's right mouse click, run Python file in terminal. Hold your breath. What happened? It didn't like it. What happened? Why did that not work? Why did that not work? Let's see if we got an error here somewhere. It didn't like my CV2 wait key. What did I do? Oh, remember how I was telling you about how capitalization mattered? Watch this. The K should have been uppercase, but watch this. If I say wait, look at that. It was trying to tell me the right way to do it. You see the wait key? It was trying to tell me the right way to do it if I would have just selected that. Now let's run. That one really scared me, guys, because I thought I'd done this right. Okay, hold your breath. Run Python file in terminal. Boom! Look down here. Look down here. I have a window. Hi. Okay. Why am I so small? Why am I so small? Okay. I'm small. Let's see. Let me turn it here where it will look more towards me. More naturally towards me. Okay. There I am. Okay. And then I'm going to adjust this. And you know how I love to have all these things kind of looking good. So here's a camera that I have looking down at the camera that is looking back at me, but I need to get it to focus. You know what, guys? I cannot stand having a camera out of focus. So you're just going to have to bear with me till we get a good focus. Okay, now just stay there. Stay there. Don't get out of focus. I'll call that good. If you'll call it good, I'll call it good. Okay, so do you see the camera is looking back at me? Okay, I am not exactly happy with that. Let me show you something down here. If you guys will look down here, it will tell you what the possible frames are that you can do, and one of them is 3464 by 2464. So let's make sure that that's what we did here. 3264 by 1848. That does not look exactly right to me. So it's either going to be 3264 by 1848 or it's going to be 3264 by 1848. Do you see how the camera is telling you what settings it likes? And so for my screen, I think I was too much like this. And so I'm going to, for my screen, go back to 2464, like that. Okay, now don't kill the program. To kill the program, you need to come and click on the window and type Q. Why? Because we did that wait key business. Okay, 3264 by 2464. You guys look and see which one looks right. You don't want to be squunched this way or you don't want to be stretched out, and it might depend on the screen, but I'm going to try to run this again and see what happens. Notice I am changing the string. Okay, we've got to get that read value right. So now I'm going to right mouse click, run Python in terminal. That looks more right to me. That looks more right to me. Boom. Okay. So like if you kind of compare me to me here, that kind of looks right. All right. So what do you not? So how are we going to quit? We're going to queue. Now, how would we? Now, don't mess with that string. It's working. Don't mess with the string. If you want to mess with something, play with these. You kind of would want the window bigger, but try to keep this aspect ratio. So I'm going to multiply by 2 and say 640 by 480. And now let's run that. Boom! Look at that. Look at that. 1, 2, 3, 4. 1, 2, 3, 4. There's really like no latency in that. And that is really looking good. Running the PyCam on the Jetson Nano. Yes. Okay. Did you do that with me? You know, they do that on football games. I think we should do it in programming. We should really do that more. Okay, and let me quit out of that, and let me just also just do kind of a quick check. I'm just trying to kind of tweak this and make sure frame rate it wants is 28. Okay, just to be good, we use 32 by 64, and on that frame rate, it really seems to want a frame rate for that size of 21, and so I'm going to change this to 21. So if you use 3264 by 2464, you need to set this frame rate to 21. Okay, if you use 3264 by 1848, if that looks more like the right aspect ratio on your system, then you would set the frame rate to 28. You would put 28 here. Does that make sense? Okay, this is really fine tuning. Some people look at it and can't tell a difference, but I just really don't like an aspect ratio to be wrong. Okay, I'm going to make sure, yeah, that window is dead. So I'm going to come over here and I'm going to right mouse click and I am going to run Python file in terminal. Okay. Yeah, I think that's better. I think that's less drop frame. 1, 2, 3, 4. 1, 2, 3, 4. I think that is good. That looks really good. Okay, I'm going to queue out of there. And what if we did, like, the next one would be like 1280 by 4. This would be like 960, something like that. Let's see what would happen there. 1280 by 960. Run Python. Oh, yeah. Okay, we got a big one there. All right. Oops. Okay, let's try it. 1, 2, 3, 4. That really looks good, right? That looks good. What you notice is it doesn't, that the Raspberry Pi camera doesn't really have the white balance fine-tuned, that if you look at me here in the real shot, that camera has it's white balancing correctly, and and the Raspberry Pi camera isn't quite balancing, but we're not going to worry about that because this is really, it's like a high resolution, there's no lag, it is really looking good in my mind. So I'm going to cue out of there. All right, guys, this is pretty exciting to me. Oh, and just so that you know, these are the different ways that you can configure the camera down here. And really what the best thing is to configure it in a high resolution mode and then just up here display it in a lower resolution. So I would not mess with this string once you get it right, and grab it at high resolution and then display it at low resolution. That is what I would suggest that you do. Okay, and this shows you all the different ways you could set that up. 3264 by 2464. You know, you could come down to like 1280 by 720 and do a frame rate of 120, but don't mess with that stuff. Okay, let's look down here, and if you notice when we launch this thing, we get this error message, failed to load the camera module, and that doesn't really hurt anything, but I hate having an error message, and I can show you how to get rid of that. Let me make sure that I killed, yeah, the camera is killed. Come over to a terminal, and this is the command I need you to do. I need you to do sudo apt-get install and then libcanberra, libcanberra-gtk-module. So somehow on the NVIDIA image that we got, there's this little library you really need. So let's go ahead and install it just to make sure that we don't get that error. I don't think it hurts anything, but I just don't like getting errors when I run programs. Okay, that looks good. Now let's go back to our Visual Code Studio, and now let's run that again, and let's see if we get the error this time. Run Python file in terminal. Boom, there I am, no error. Do you see over here? No error. Okay, let's quit out of this. Okay, now most of you, I think, that have been playing along at home, most of you got the Raspberry Pi camera. But some of you are out there saying, hey, what happened to those of us who got the webcam? Those of us who got the Logitech webcam, because that's one of the cameras that I linked to. You can either use the Raspberry Pi camera or you can use the Logitech camera. What do you do in that case? Well, what I'm going to do is I am going to show you how you launch that camera. It's actually a lot easier. So what I am going to do is I am going to comment out this cam. Okay, and then I'm going to come down here and I'm going to make a different cam, and that is going to be cam equal cv2 dot video video, and there you see how it has capture. Oh, that was not good. I'm trying to get kind of better. Okay, video capture. And then now, instead of that long complicated string, since it's a supported webcam, all you got to do is it's either going to be 0 or 1. Well, since I have the Raspberry Pi camera already on there, that's probably 0 for me. But you can't launch the Raspberry Pi camera by just calling 0. You got to do the GStreamer. But for a webcam, all you got to tell it is it cam 0 or cam 1. If it's the only one you have, it's likely cam 0, but if it's not cam 0, it is probably cam 1. All right, and then everything else is the same. I've just switched cameras, and so let's see what happens. Hold your breath, right mouse click, run Python in terminal. Whoa, look at that on the webcam. On the webcam, you see I'm putting my hand over here by the Raspberry Pi camera. It's not the Raspberry Pi camera, it's the webcam. Okay, but notice everything else is working the same. And let's kind of check our latency here. I like to 1, 2, 3, 4, 5. You see, good, moving, not getting all jittery. Ooh, I should put that where you could see it, right? Okay, 1, 2, 3, 4, 5. Moving around, not jittery. That is really neat. So that's the webcam. Okay, that's the webcam. So you guys that are on the webcam, it's a lot easier than those of you who are doing it. But this is what I want. I want this to be your core starting program. And if you want to use the Raspberry Pi camera, just comment out this. And if you want to use if you want to use the Raspberry Pi camera, uncomment this and comment this. If you want to use the webcam, comment out this and uncomment out that. So now always save this and just uncomment out based on the camera that you are using. So now what I want to do is here in this OpenCV, I want to create a new program. So I'm going to say new file, and I'm just going to call it PyScratch.py, and this is going to be a program I play around with. I'll just leave it there. Anytime we want to play around with something, we can play around with it. What I want to do is I want to come and get this program because, right, I don't want to mess with this one. This is the one that will always be the starting point for what we're doing. So I'm going to copy it, and I'm going to come over here, and then I'm going to paste it, okay, like that. Now, look at this. I've got cam set to the Raspberry Pi, or I have cam set to the webcam. What should we maybe try to do? Do you have an idea? If you're in the Premiere, tell me what you want to do just to try. Do you think we could run both cameras at once? Both cameras at once. Well, you can imagine that I can't have the same object going to two different cameras. So let's call this one the Pi Cam, and let's call this one the Web Cam. All right. Now, what do we need to do? We need to come down here and we need to read from what Pi Cam, and then we also need to what? We need to RET, and we need to read. Don't put it in frame because you can't put two pictures in the same variable. We'll call it frame 2. And this will be from which camera? Webcam. And that is going to be .read. Okay. Now, if I read twice, I better what? I better show twice. So I'm going to do cv2.imShow. Now, you can't be putting both images in the same window. Now, you know, once I say that, it makes me want to do it. What it's going to do is if I put it in PyCam, and I put this frame 2, you know what this is going to do? It's going to have one window, but it's going to be going back and forth between the two cameras. I think I shouldn't play around like this, but I can't help it. I just want to try that and see what happens. No, it seems to just do the one, so that just kind of didn't work at all. What it seemed to do was just go to the webcam. Okay, so what it ended up doing was just kind of the second one, the webcam, which was frame 2, it just kind of kept doing that one. And so what we will do is we will make a second window. In this window, we are going to call it webcam. You could call it whatever. It's just something that sort of represents what it's doing. So we should get how many windows this time? 2. Run Python file in terminal. Ah! Look at this. Boom! Boom! Okay, why is PyCam so big? Because on PyCam, we set the display width and the display height. Right, on the PyCam, we set the display width and the display height when we launched it. But when we did video capture, when we did CV2 video capture for the webcam, that was just using the default values, and this is kind of just the default values. Okay, in fact, let me kill this, cue the program, and then let's go to our programs up here and let's run Cheese. Cheese is just a canned program that runs the webcam, and do you see it's like that same size? It's the default size as when we were doing it. Okay, so Cheese is just a Linux program that runs the webcam, and you see that is the same, it's that same default size as if we did run Python file in terminal. Okay, and then you see this looks like the same size as when we were running it in Cheese. Okay, let's see, 1, 2, 3, 4, 5. All right, so up there in the corner is the webcam. Okay, the big one is the PyCam. If we wanted to kind of make it about, it seemed to got a little glitch there for a second. Okay, if we want to make it the same size, I'll quit out of there. Probably that was more like 640 by 480. Okay, right mouse click, run file. Okay, I think these are about the same size now. Boom, look at that. Wow. Okay, man, I'll tell you, I am really excited about this, the fact, because darn it, this is really cool stuff. Okay, this is what I want you to see on this program. Let's go back to our first program where we were just running one. We fire the camera here, we fire the camera here, and then we read a frame, and then we show the frame. Okay, you see this here between read frame and show frame? That's where the magic happens, because you think of a movie happening really quick at like the 28 frames a second or 21 frames a second or whatever, you think of it happening really quickly. We have all the time in the world to create mischief between reading the frame and showing the frame. We can analyze the image, we can add to the image, we can take from the image, we can change the image, we can manipulate it, analyze it, do all types of different stuff, because we sit in this spot between reading and displaying. And that, my friend, is where the magic is going to happen. And so as these new lessons go along, what we are going to be doing is we are going to be doing some really, really cool stuff between reading the frame and showing the frame. Okay, I wonder, like, if I could even, I always hate it because I always think that I'm going to show you something, and I really shouldn't. I really shouldn't go in and start doing these things on the fly because they rarely work out. Let me see. Let me just see if I've got one here that will do something. Let's see. I'm just going to try to run some of the programs I've done before. I really shouldn't do this, you know that? Look at that. This is the edge version of me. What do you see? You see edges. Okay, well, edges are actually really important. They're really important things. Okay, that was kind of cool that it actually worked. Okay, and then let me see here. Let me see here. It's always the challenge of me deciding to do things on the fly. Okay, it's always the challenge of me trying to do things on the fly. Okay, here's something that might be interesting. Okay, I got a Sparkfun box. I love Sparkfun. I order a lot of stuff from them. Let me see if I can come over here and run this. Let me just see if this will run. Some of these aren't really set up to run. I've just been playing around, so let's see if this one will run. Okay, well, it kind of messes it up because I'm wearing a red shirt. I'm kind of wearing a shirt that's almost red, but the purpose of this program is to find the color red. And do you see what I'm doing? I'm tracking on red. And what I guess I need to do is I need to get out of the camera. Okay, and then look at that. You see how I'm targeting it? I'm finding it, I'm outlining it, and then I'm targeting it. So you see, that is really pretty cool. Now this is what you got to think about, right? Because we have those GPIO pins, I could be moving something based on those crosshairs, right? I could have servo set up and I could really be tracking this thing or aiming something at this. So all of a sudden, all types of crazy things start happening. Let's see what else I'm going to do here. Let's see. I had some cool stuff here. Okay, let me see if I can do this. Okay, and guys, these aren't just copy and paste things. These are things you're going to be doing from scratch. And look at that. What's it doing? It's finding my face and it's finding my eyes. I used to have a smile detector on it. No, I turned the smile detector off, but it put a red box on a smile, but I don't have that turned on right now. Boom! Do you see this? And this stuff, guys, you're going to be doing, and you're not going to be doing it based on copying and pasting. You're going to be doing it based on sitting in that magic position between reading the frame and displaying the frame. So we come in here and we recognize faces, and then we put boxes around them. Or we could recognize specific people, or we could recognize objects and then track them. And so, guys, that is where we are going, and I am so darn excited about this. I can't tell you how excited I am. Okay, guys, leave me a comment down below. Were you able to get these things working? Do you have your camera up and working? Are you as excited as I am about this? All right, guys, we are really getting into it. I know a lot of you have been impatient because of all the groundwork that I built. You wanted to just jump in and do things, but now you understand Python. You understand Matplotlib. You have the right version of OpenCV on your system. You have kind of done a review on Python. Man, you got this groundwork done. Now we are going to do some really cool stuff. So anyway, appreciate you guys tuning in. The stuff is really going to get fun at this point. Those of you who have stuck with me, the stuff is really going to get fun at this point. Would love to hear your comments down below. Think about giving us a thumbs up. When you give me a thumbs up, it actually helps me in the Google algorithm, where YouTube will start recommending this video series to people. So you really do help me if you give me a thumbs up. And again, really appreciate you guys who have decided to become a part of this channel by helping me out on Patreon. Really, really appreciate it. It's a huge encouragement to me. Okay, this is Paul McWhorter from TopTechBoy.com. I will talk to you guys later.